Test. Hello world. My name is Stefan. In the web I go by Flashover, and I'm back. I skipped the last 2 Sunday streams. I was preparing, and then the week afterwards actually have been at the Developer Week in Nuremberg, where I actually gave 2 talks about nullable reference types and, of course, what else? Source generators. And also met some fellow peers. I had a great time there, and also just have gained a new follower. Hello, Loud Rowdy. Thank you for following. And I guess the key takeaway of the Developer Week for me is that about testing, I was way too dogmatic. What my takeaway is, the most important thing to test is the public surface area. Well, if it's a library, it's the public methods. If it's an API, it's the actual HTTP endpoints. And perhaps not everything should be mocked. If it's a database, maybe spin up a local Docker container where you actually host the database to have a more thorough test. So in the future, I will use mocking less and be more aware of tests with purpose. And if a test fails, what I also took away is that the message that you get should be quite revealing of where the actual error may be. And also this week, on 3 days ago, at the .NET Devs.at, I will post the link into the chat. In Vienna, we had the IL Spy team at our last meetup. So you can go to our YouTube channel if you missed that and watch it later on, also putting that link into the chat where we had the ILSpy team, two members of the ILSpy team at RubyCon, and had 2 talks about how ILSpy is working, how the decompilation engine, the most important part, is built, and also an AMA session at the end. And Matkoch is going to Austria today, actually. I hope we get to meet next week. I'm really looking forward to that. So this pretty much sums up the most interesting activity of the past 2 weeks for me, or past 3 weeks actually. Almost, because I also continued to research about the issues that I had last time with benchmarking of the incremental generators. So in the session before, 3 weeks ago, we finished the diagnostics part, where we have this syntax. Actually, let me show it. Where we are, let's jump to a test. Using this syntax where we have this open brace, pipe character, number, then and not really an index but some identifier, an integer, colon, then comes some source text finished by a pipe and a closing brace to indicate that this code, that this is the location of the diagnostic with the key 0, that we can then actually hook up with an ID, a severity, a message if we wish, and so on. But one part was missing, the analyzer config options. And in that session, where I kind of, rabbit holed myself into, is trying to create a compilation and adding the global, the analyzer config options, I tried both the .global config and editor config, and adding the settings, adding also a key value pair combination, but it didn't really work out. The analyzer, no, not the analyzer, but the source generator didn't really see that config option. It always was empty. Where I then eventually found out, took me perhaps a bit too long, that I shouldn't be doing this in a separate compilation, but actually pass it to the generator driver. So if we go to our benchmark type, which in the initialization phase actually creates a C# generator driver, and this C# generator driver is actually accepting the analyzer config options. So I should have passed it into the generator driver, not to the compilation. And then it worked. So let me actually show a test. So I have here a test. If we don't set any, in the initialization phase, we say nothing special here. We expect that analyzer config value of this key is not found. But if we actually do set the analyzer config options, that I have then went ahead and defined as an I collection of string key and string value. Previously I had a dictionary of key value, but I actually wanted to give it a name. So I'm using here the C# tuples, value tuples within a collection to have the name key and value specifically, not specifically, explicitly. And perhaps later on, I may actually refactor this into a separate type to have a really like typed solution, and perhaps then add some members if it makes sense. But that's perhaps for future refactoring. And then actually, if we do have some analyzer config option set in this key value collection, I then create a new type, an ad hoc analyzer config options provider, because this config options provider is an abstract class, and in the Roslyn packages there is no public implementation of it. So basically provide my custom implementation. So far I only support the global options in order to support the get options by syntax tree and get options by additional text. If perhaps some user, I didn't need this so far in my generators, but perhaps if some user needs this later on, well, we could still implement it. And for the global options, again returning a custom analyzer config options type, because again the analyzer config options type is abstract and there is no public implementation of it. There's only internal implementations of it. So providing a custom analyzer config options type, which basically now receives this I collection from what the benchmark author has set and creates an immutable dictionary out of that. Could also have been a regular dictionary, but since it's Roslyn, I kind of go with the immutable versions of it. And then in the try-get value, calling the try-get value of the dictionary. That quite seemed straightforward. And then if we have a look at our generator that we use and go into the execution method, we have here we grab the analyzer config options provider, go into the global options. That's pretty much the same code as last time, just a bit more explicit. And if we do find it, if we do find the value, then we print out the value. Otherwise we say not found. And when we run the tests, they are turning green. We see we have like two test projects here, but they're both incremental generator. So what I did here is I also refactored a bit the package. This is the other significant change that I did off stream. The rest is at least pretty much the same. I started multi-targeting. So I'm multi-targeting for NetCore 3.1 and NetStandard 2.0. We need to at least target NetStandard 2.0 because that's how Roslyn components work, analyzer, source generator, refactorings, and so on, because they need to both work in Rider and in Visual Studio, and because Visual Studio is a .NET framework, but also needs to work in Rider. Rider is using, I believe now, or in the upcoming version, .NET 6 under the hood. So it needs to work everywhere. This is why we still, for Roslyn components, still have to target NetStandard 2.0. But since the Microsoft Code Analysis C# package, if we jump to nougat.org, go to the dependencies, we see this, it also targets NetCore 3.1. So I wanted to reflect this capability and targeting both here. And for testing, we also do multi-targeting. This is how we basically have two test projects to run in the Test Explorer. Same with other IDEs or with the CLI, of course. Targeting the latest not core app compatible target framework Net 6, and also the latest Net Standard 2.0 compatible framework. So if you put them side by side, or not side by side, but top to bottom, I'm using Net 472 to test the Net Standard 2.0 target, and using Net 6 to test the Net Core 3.1 target. Okay, and this pretty much is the changes. So we now have everything from that the source generator or incremental source generator supports, which is syntax providers, which is the compilation, the parse options, additional texts, which are not C# text and are marked in MS Build as additional texts, the analyzer config options now finally, and metadata references, where we last time also discussed a bug in the Roslyn 4.0 incremental generator, where this is defined as a singular metadata reference, where this metadata reference provider here is actually defined as value provider, not values provider. So in our test, we only got the last one, not all of them. And since Roslyn 4.2, this is fixed to be the values provider, and you get the full collection. And this pretty much is now the first implementation, the first complete implementation of benchmarking incremental source generators. Now I would like to do is this an integration test? Actually, use this at one of my current generator projects. So if I switch solution to this project, I think I showed this at some point of time in my previous streams already, where I guess the most significant generator here is the enum info generator. Let's briefly jump to the benchmarks. To the generated benchmarks, yes. So we have a build error. Okay, but if we would ignore it, it generates a enum_info.getName is basically doing the same as the toString of an enum. We have here log level none from the Microsoft.extensions.logging package. And enum.getName also pretty much does the same as enum.toString, but this generated version is significantly faster because it avoids reflection and basically does the selection of the string that should be returned at compile time. And here we also have integration tests, and I would like to replace them. I hope I get the tests running. Looks good. And we do have benchmarks of this generator here as well. Okay, don't mind the errors that Visual Studio is displaying, because I believe that's a lie. Tests are running fine. And yeah, for example, checking the generated string, doing string comparison, and having both, then some initial code. Perhaps I zoom out a little. The details are not that important, but in the setup, have some initial code, initialize it, then in the actual benchmark phase, invoke it a lot of times, and then in the cleanup of the generator, then having the inspection phase, where in this case, we only see if it's basically the same string that we expect that's generated. So let's try that, if this is actually working. So I'm going ahead and I have here the C# code measurer that I used so far, and I will just remove that. Oops. So now the compiler errors are for real. And not sure why we do have compiler errors. Is it because I'm using a wrong global JSON? No, looks good. NuGet config also looks good. Not sure what the issue is. But let's try to add that. Well, I'm not adding it as a package, but as a local reference for now. Incremental generator. Browse. Not seeing. Projects. Okay, because the project isn't part of the solution. Then let's add it as part of the solution. Not new project, existing project. I think this project has no dependencies. Yeah. And in the benchmark, let's now consume it. Add project reference, incremental generators. Okay. And let's go to the generator. Now let's replace in the type. So this should be the, not sure how we called it actually anymore. The C# incremental generator benchmark. Yes. Let's import the using. Okay. So we create the benchmark. Now the initialize doesn't take the code, but it takes a C# incremental generator initialization context. Let's set the code. What members do we have? We have source, and let's set this to code. Okay, and then we do the invocation. We have two methods actually. We can invoke or invoke with memorization. This is what the big advantage of incremental source generation is, where you build up your pipeline, and if a previous step produces the same result as in a previous iteration, the next step is not executed, but the cached result reused. Because, yeah, same input, same output. And compiler is deterministic, or should be deterministic. And for the generated code, in the inspection phase, we add the inspection context, see what members we have. We have source, and set the generated code here. And this does not compile because, yes, this is a tuple, isn't it? Yes. It also requires the hint name. So how is this file called? Not sure. Let's enter something wrong and see if it actually is failing. But there is a second benchmark for the friendly name generator, which basically, yeah, what we see here, it's almost a name of, but for the actual the actual type that we pass in here. So if we write int, so it includes metadata and also generics. It also enables generics, but this is not like compile time constant. It's evaluated one time. It's nice. It's not the fastest thing, but it's nice. It's convenient. I use it for error messages. I don't use this in if performance is critical. C#. What was the name? C# incremental generator benchmark. Let's use that one here as well. Add the using. get rid of the old using, okay. And same game, initialization context, set the source to code. And then we have the invocation phase. Actually, I do have this, the invocation phase returns, so we could shorten it like so. And then we have some capacity, okay, and generated new inspection context and set the source to, I'm not sure about the hint name actually again, so I will enter wrong.cs and the generated code. And let's see what happens if we run that benchmark. .NET 1 C release, because benchmarks usually are one in release. Okay, I'm still using detected package downgrade. Okay. Oh yes, I can get rid of the diff package, so we don't need the diffplex anymore. And this should be fine. Okay, I'm still having the measures here. Okay, there is a third benchmark, the source generation exception generator. So one more benchmark generator that I have here, C# incremental generator benchmark. And again, using our context, setting the source as an input and expect, here we have diagnostics. Okay. New, so as source, again, I'm not entirely sure about the hint name, hint name.cs, and the diagnostics. So we can set diagnostics, but I guess this is, it's a collection of ad hoc diagnostics. Okay. So how do we create these? Where did I set, how did I set the location? I didn't set any location actually. So, but now we have a location. So where do we expect? The diagnostics here actually. So let's use the syntax. Then we have number 0 column. 1 and 2, and then close it here. For the others as well. Oh, sorry. Let me zoom in. So here, here, and here, without the semicolon at the end, we expect the diagnostics. So we have 1, 2, 0, 1, 2. And so this is like the message. Let's add the intake position 2. Let's call it int markup key. And we should now return a new ad hoc diagnostic. Not sure, I think I define it as init only. Yes. So let's set the ID to the ID here. Let's set the category to the category. We have a message. We have a severity. What else do we have? Description, help link, markup location. Okay, but we can set the markup location also via the constructor. So let's put it in here. Okay. And now it should compile. It does. So let's run the benchmark again. It should fail for this hint text that in the inspection phase fails. So let's run the first generator, the enum info generator, and we get a message failed to execute because we expected wrong.cs, but it was actually enum.info.g.cs. Okay. Perhaps let me also do an error with the diagnostic. Let me add here something and let's see if this one fails afterwards. But first fix the enum info generator benchmark. It's not wrong.cs, it's enuminfo.g.cs. The .g stands for dot. You could also write .generator.cs, which is an indicator for tooling such as Roslyn that analyzers shouldn't run generated code because the user has no influence on, or no direct influence on generated code. And some, let's say, nullable warnings quite wouldn't make the user happy because they can't really fix it. Let's run the benchmark again. And it doesn't fail. Okay, although the ID of the diagnostic, I may have a bug. Oh no, I set this in a different, never mind. I set this in the source generator exception. So this was in a different benchmark. So far everything is great. Benchmark runs, okay, cool. And so we have like 500 nanoseconds. Let's also try the with memorization. Now this should be significantly less. Because, oops, I closed the terminal. .NET 1-c.release. This should be now significantly faster. Yes, because it's only basically generated one single time and then the result is reused for subsequent benchmarks. Just see if that works as expected. Then we are also trying this with the other generators, see if everything is fine. Then I have a second project where I'm actually using something else as well. Want to test this as well? Yeah, so this is not 500, but like 8. Not milliseconds, I said milliseconds, but it's microseconds. Okay, so that looks good. Let's run the other benchmark. We should again have an issue with, yeah, so it's not wrong.cs, but it's friendly.g.cs. Perhaps let's also make another error in the, it's the friendly name generator. We expect a friendly.g.cs. Perhaps let's also add a mistake here. Let's do a, remove a question mark here. So this should print an indicator of where the string differs. Yeah, so we have here the expected string and we say here, okay, we have here the minus. So we expected int here, but we actually got int question mark. So this looks great as well. Let's revert that and let's run the benchmark. Okay, I will not let this finish, but this looks good. And for the last one, the source generation exception generator. Yes, here we have unexpected ID of the diagnostic with markup key 0. We expected the one with the suffix that we added, but it's actually without the suffix. So this works as expected as well. And now we should get the, Now that's weird. Oh, okay, I think the error message here is misleading. Because I think the message actually doesn't match. Inspection. Yeah, okay. It's the... I think I can debug this benchmark, because we set for, if debugger is attached, we're using a debug configuration. So we can actually run this benchmark in debug configuration. And see. Okay, I hope this doesn't take too long. But there is something else is not matching. I believe it's the message, but we, yeah, always print the same. Need to split that up. So we expect the message, but the message of the actual diagnostic. Let's see how this line, what this line evaluates to. It does evaluate to false. Okay, then it's something else. Is it the severity? Okay. Ooh, then it's the location. Oh, it's the location. Yeah. Okay. So the location is off. Perhaps let's say unexpected diagnostic. And we should also how do we best do this? Let's say, yeah, let's do the ID. Actually, let's use as message, let's build the location. Okay, let's have this one and also add actual dot location source span actual location, expected location. I did check this actually. I can suppress this warning here. Oops, I should also zoom in here. Compiler error. Message dot toString because I changed the string to string builder. And now we should get a better message. Yeah, so okay, I will improve the message of when a diagnostic is not equal later on. So the functionality looks good, but the message is not all too revealing. So we are off by a bit. Okay, this may be a bug in the logic where we find out the location. Let's have a look at the benchmark. Because that looks actually all right. We have the spans here. I think the syntax should be fine as well. 0, 1, 2, and we expect 0, 1, 2. Oh, actually include the semicolon, it seems. Then let's move that. No. Let's have a look at the actual generator. So, well, can have 2 of it. Let's search for the. Oops, I hit the wrong key. Go to the generator. Let's see the report diagnostic. We get the location. Okay, it's the location of the node, and the node is let's have a look. Let's want to test. A test which expects diagnostics. This one. So the node is okay. And okay, so I'm not for the location, I'm using only the type and not the entire expression. It seems. Okay, then that means for actually had a wrong expectation, but I don't want to change the actual generator. This would be a different task. So I think it's not the throw new here, which is but just the type. So I'm narrowing the scope of the location that we expect. Let's see if this is now. I wrote this generator like a year ago. I quite can't recall the details exactly. So I had to have a look at the test how I defined it. And okay, So this is now, the location is now fixed. Now we have the same issue as before, I'm using the wrong name. Actually, let's go from another perspective. Let's have a look, since we have the generator open already, where we add. Let's go to the add source method. We have here the hint name. So this is where context.add source, where the actual source is added to the compilation. And the hint name is source generation exception.g.cs. So let's use that in the inspection phase, other than hint name. And this should now let this benchmark 1 as well. And it does. Okay, so inspection phase here is great as well. And this concludes the first generator project I wanted to test it against. Okay, what I want to do is to improve the error message for the diagnostics. So here we need a to-do improve error message. I will revert what I had earlier. No, that's good. To improve error message should show diff. Okay, and a second project I want to test it against is this one. It's called fco.compatibility, where I only have one single generator. The is external init generator, which basically generates the is external init type if it's required. And the is external init type is required. Let's have a look at a test. If what we see here, okay, again have compiler, or Visual Studio believes there are compiler errors, but everything is succeeding. Where we have the system.runtime.compiler services.is external init type. And this exists since .NET Core .NET 5. If we jump to the help, we see the Microsoft documentation is external init class. It's available since .NET 5. And because in C# 9, the init only keyword for init only properties has been added. But the compiler requires not only C# 9 features, but also a BCL where the is external init type is available in order for this feature to work. But well, it doesn't necessarily need to be from the BCL. It could be any type. So you could declare this type manually, internally, to also use it for lower BCL versions. If you, for example, enable C# 9 for a .NET Standard 2.0 library. And I have here the has system runtime compiler services is external init preprocessor directive, or constant, which in a directory build.target files is defined as using the is target framework compatible. So if it's compatible with .NET 5, then we have this type available. But if we don't, then we want to generate it. So if this type is available, we can say type of .object .assembly. So the expected location of this type is from the BCL. But if it's not, then it is actually from this assembly. So we are here in the in the assembly where this test is actually in, because the generator is basically producing it for that consumed project. And if we switch, let's say for net 472, where this isn't there, we see also, okay, now it's coming from the generator. And so this is what the generator does. So we actually have as input different reference assemblies, and that's the inspection phase should support this also. So let's add the project to this solution. And let's jump to our benchmarks. So let's have a look at here's the benchmark. Again, I'm using here a custom measurer. I will delete this one entirely. And yeah, now we can use the C# incremental generator benchmark type from our new project. Add reference to benchmarking, yes. And yeah, here we see that this test is actually setting the reference assemblies to netcore app 3.1 where this property is not available. So we expect all of these. Which means that, let's grab that, set the new initialization context. We need to set the source. And also the metadata references. Should be compatible type, yes, because that's a enumerable of metadata references, and this is also enumerable of portable executable references, but they, I believe, implement metadata references. Excellent. This is actually from the package, I forgot the name, basic.reference.assemblies from Jared Parson, I hope I pronounced the name correctly, from the compiler team, where you can, where we get the metadata references of, for example, in our case, netcore 3.1 in a very simple way. And then for the inspection phase, we only have source that we expect. Again, the hint name, I believe, is external init.g.cs. But let's make one error. Let's use a newer. Let's use net6, or actually net5, where this type is available. So this means now no code should be emitted in the first place, because the type is available. Let's open a terminal. .NET1.c release. Benchmarks should be run in release configuration. And what is the issue? We have a compiler error. Something measures. Oh yeah, I should have removed the old namespace from the type that we removed. And let's run the benchmark. Yeah. So we expected 2 syntax trees, but it was only 1. So the input syntax tree, no additional syntax tree has been generated because the isExternal init type is already available. So let's switch to netcore app 3.1, where this type is not available. Now the generator actually should kick in and generate some code, which should now, now it goes into the generation, so inspection worked. Cool. So other than improving the error message for the locations, I guess this is almost complete. One step, there is 2 more steps. One step I want to do on screen now, versioning. And the other step is documentation. I will write this off stream and then publish the package as soon as I have the first draft of documentation complete. About versioning, I want to use a pre-release version. So I think in the directory.build.props, I defined something already. So here we have all the NuGet properties. Do we have version here? Yes, so here's the version. I set it to something in a different file actually. So if we change the version, there is only one file to use. I guess I should also look into other means of generating the version. But for now, for the pre-release phase, I would rather set it manually. Yeah, so I set it to 0.1.0, but I actually want to use a pre-release. And the pre-release for NuGet is when there is a dash, so something like dash pre-release. Now it's a pre-release of a NuGet package, and in tooling, for example, in Visual Studio, but also in Rider, you now need to check if we want to include a package. Just go to the Package Explorer. You need to hit this Include Pre-Release checkbox if you want to actually see it. Same with Rider. And without that, it's not a pre-release, so you can see it without the checkmark as well. And this is due to semantic versioning. In semantic versioning, pre-release, we see, by appending a hyphen. So we have here a pre-release 1.0.0.-alpha. Perhaps let's also do 1.00 in our project, not 101. And for the pre-release, I would like to, there is two properties that I always forget. .NET version, I think it's from Andrew Locke. .NET version suffix, yes. So there is version prefix, version suffix, and version. And I believe version per default actually consists of version prefix and version suffix. So let's use that. Let's duplicate this. Let's say suffix and prefix. Oh, perhaps the prefix should be first. And in the version prefix, we set 1.0.0. And in the version suffix, we set, I'm not sure. I like to have a look at how Microsoft is versioning their packages. Let's have a look at Microsoft.extensions.logging. Well, let's actually have a look at the compiler. Microsoft.codeanalysis.c#. And there should be a pre-release already. So if we jump to versions, yeah, we see so they have 1.final, 2.2.final. That's weird. I'll call it pre. So we have pre 1. How many digits do I need? So that it, in order for it to, so that it orders nicely. Because if I would have like later on a pre2, and then go to 2 digits because I have more than 10 or more than 9, and then I have pre10, I think from ordering it would be then like so, but not like this, because it's only like string ordering, and no, it's not really, the suffix doesn't really contain a version. So perhaps I use 2 digits, but if I need, I would like to publish one pre-release per type. So how many types do we have? Let's jump to the issue. Oops, I had it open already. So we have analyzer, code fix provider, refactoring, suppressor, both generators, that's 6. And for C# and Visual Basic, so that's 12. Okay, so I'll do 2 digits dot 01. Without the dot, with the dot, with the dot. Okay. this should be the version. So let's use that other than, but let me copy that so that I don't have any typos for the version prefix. Yeah, so the version prefix should be in a major minor patch format. Version prefix should be my prefix. And version suffix is like an alphanumeric plus hyphen string. Let me check again. Yeah, it may also include dots. Dots and hyphens. So that's the version suffix. Let's set the version suffix to my suffix here. Okay. Prefix, suffix. And if we build, actually only allow this one project to build. All the other projects that we haven't implemented yet, I do have the CS projects here, but I say is packable false for now. So if we go to the solution and do a .NET pack, it doesn't. Is it not pack? .NET create a NuGet package. Perhaps it's generated already. I thought that it shows the location of where it has been generated. No, it's not generated. Also, okay, I do have is packable false here as well. Since we are complete, we can remove that. Now it should. Yeah. Successfully created the package. Is this right? Okay, I'm not sure if my version is working correctly. It doesn't. I was expecting that it includes the pre-release. But it doesn't. Okay, what I'm doing wrong. Go to the directory.build.props. We set the version prefix and the version suffix. And in the release, let's see, I have no copy paste error. Maybe a dot isn't allowed. Okay. I'm not sure about the error, but let's try to set it directly. Let's say version is version prefix dash version suffix. It's not a valid version string. Okay. I'm doing something wrong. Because I thought the version is actually version prefix dash version suffix. Okay, I'm not entirely sure about the error I'm making. Version prefix dash suffix. What if I like write it directly 1.0.0 pre-01 pack? That seems to work. Okay, that looks great now. I guess I misunderstand those properties. Yeah, and here it is now, pre-release version. And we open this in the NuGet Package Explorer. We actually see this is marked as a pre-release. Okay, cool. I'll have a look at what I'm doing wrong with the versions here. And yeah, so I will have a look at the correct pre-release version and also at the documentation, and then I will publish the package in the next couple of days, latest, but no later than the next stream in a week. And I guess this is the first milestone that we followed up, and okay, not yet, I still have to do the, I will not mark it as complete yet, documentation and better message for locations. And also pack and publish, yeah, I'll do this off stream, have a look at what's wrong with the version, and also, yeah, automate it via a pipeline or an action workflow. And now I would like to start implementing the same thing for AI source generators. Which should be, I expect, because yeah, source generators and incremental generators are quite similar from a driver's perspective. Shouldn't be much than moving code to base classes, which are then shared. But let's start at the beginning. Let's go to the C# source generator project, to our tests, and let's do something similar then with the incremental generators. So we have let's build a C# source generator benchmark tests. Should be public. And also we need an actual source generator that we use for testing. So let's have a test C# source generator, which is mostly in 3.8 AI source generator. And unlike we also need the generator attribute, set it to language names.c#. Unlike the incremental generator, has two methods, the initialization phase and the execution phase. And there is no memorization, so everything is executed all the time which for huge solutions may slow down editing experience. Okay, so let's have a fact. Perhaps I'll get inspired of the previous test. Does it make sense to get really inspired? Because pretty much should be the same, shouldn't it? It actually should be. So I will, but we have no memorization yet. So let's copy these two tests and get them working for the incremental generator, the non-incremental generator. So this is now a C# source generator benchmark with the source generator that we use here. Okay. Same for the test below. Default hint name, I guess this is a member. Okay. C# source generator. But this type doesn't exist yet, so let's build it. Let's go to the production project. Just similar to the incremental generator, let's have a C# source generator benchmark. This one needs to be public. It is generic of T source generator, where T source generator is I source generator. And it also needs to have a parameterless constructor, an accessible parameterless constructor. Let's have a look at the incremental type. The signature should be quite matching. It looks good. And I guess then we can should just be able to move over some code. Perhaps I grab the, as a start point, I grab the, yeah, we have the context. Okay. Do they differ? I guess they don't. There is nothing in here which the source generator shouldn't support. Same with the I guess we can just make this incremental generator benchmark inspection and so get rid of the, so just generator. Let's get rid of the incremental or source generator part and make them usable for both. Okay, so, but we do have differences because one uses a source generator, the other one an incremental generator. So for now, I will go ahead and move everything to a base class. So we have let's have a look at the project structure. How did I plan to do this? So here we have the incremental generator, here we have the source generator. I guess, do I need to put it to the benchmarking base type? I guess so. Well, I could have a shared package for just generators, but Perhaps we do, or do we just, let's put it into how the project was, how I planned it initially. But let's put it into the C# benchmarking base package for now. I'm not sure about the super base, which is then both used for Visual Basic and C#. So I'll put it into the benchmarking project here. But may this be an issue? Yes, because this base package, it should be a rather low version. Currently I have 4.2, but it should be a lower version. What's the lowest version that we need support? I think it's 3, isn't it, for analyzers. So what is C# diagnostic analyzer? So this is an analyzer, and this is available since Roslyn 3.0. Okay, so this should be the lowest version, which means actually this base package should be 3.0. But we don't have generators here available just yet. Okay, now there are two options. We either have a shared generator project, or we duplicate a lot of code. That sounds unpreferable. Or we refactor most of it into some shared and then use the same logic in both. Because the generator driver, this is available in 3.8 or 3.5 as a preview. No, 3.6, there it is. Okay. Yeah, but we will be targeting 3.8 because I think in 3.6 and 3.7 it was still preview. 3.8 was the release of the .NET 5 SDK in November, the GA release. So how do we best split this up? I'll go with a shared base package, base library. So this is a class library, not Visual Basic, but C#. And we call it f0.codeanalysis.benchmarking.generator. How did we call the others? C# incremental generator and C# source generator. Add new project. Not .NET. Oh, not .NET Framework, but a C# library .NET Standard. Yes. And we just call it generator. Generator.benchmarking. And we put it into the source folder. Okay. That's standard 2.0. Let's remove this class 1. I'd like to have a benchmarking namespace. CS project basically copy over. And then fix the naming. Okay. Yeah, we just do there's trouble when a project starts multi-targeting, or we change a multi-target. Yeah, so let's close the solution, open it again. Still complains. Version conflict. Okay, we'll have a look at this in a second. Let's first move the code from the incremental generator. All of it to the base generator benchmarking. Oops, I created a folder. But I then overrode DCS Proj benchmarking. And we add a new type. C# generator benchmark. Let's use file scope namespaces. This is an internal, no, public. I think we can make it internal. Internal abstract. C# generator benchmark, which is non-generic. Let's see. Class. Paste in all the code here. Okay, and then we need to move a lot of logic. So I'm going ahead and going to the File Explorer. Move the, I guess all the inspection, all the markup parsing, the diffing, the diagnostics, pretty much everything can go to the general generator benchmarking. One didn't move. C# incremental generator collections. Into the base. No, it's open. Well, I'll move it later. And okay, so that means we can also from the basically, well, I did make a commit previously, so that what I'm doing now doesn't interfere with the previous version. And opened a new branch. No, I didn't open a new branch. I'll move this later onto a new branch. And okay, so this one doesn't need that anymore. And this should be at least 3.8.0. Okay, I guess now we just need to fix a bunch of compiler errors. Uh-oh. Did I lose the code now? It appears I did. I didn't save. That's embarrassing. I moved the code, so it's gone here, but I didn't save the other file. So I'm restoring that. There it is. And now properly move it to the new base. Let's switch to file scope namespaces, internal abstract. All right. Let's bring in all the usings. The markup, okay, the other types that we moved in should now go to the new names. No, the namespace actually fine. Okay. Yeah, so the context, we don't have a C# incremental generator benchmarking context, but just a general generator benchmark initialization context. Okay, so we need to move these over as well, which is the both of the contexts, the initialization context and the generator driver options are not available. Aha. Okay. Since when do we have these? Since 4.0.1, okay. So we can't have these in the base, so we do need a more derived version of it. So in the incremental generator benchmarking, we add the type back. Make it make it public and let that one derive from the base, which is without the incremental, just the C# generator benchmark initialization context, and add the driver here, okay? And we rename that into unseal it. So this one should now be able to consume it. Let's add the dependency. So this one should consume C# as a C# generator benchmarking. Okay. So this one compiles, and now we have the first context. Okay. Oops, the file name did not change. And here we remove the incremental as well. Okay, rename the file. This one can stay sealed. This is all available in lower versions in lower than 4.0 versions. Okay, now for the generator itself. Diagnostics. The driver options. Okay, they are not available. Ah, okay. So this constructor also has been updated in 4.0 to include the driver options. So we do need, perhaps I make it different. No, base package. No, I rather have the base package. Yeah, no. Let's keep it that way. One using, I don't have the additional texts. Okay, need to bring these over as well. Okay, yeah, driver options, we don't have these. So let's make a internal abstract. Oh no, if we don't have the driver options, actually, we don't have them, so we need to do a internal abstract void, no, not void, but so we need to create the driver. Create generator driver. We make this one abstract. And should be able to move this then to the I guess for now I do some copy paste. I will remove this duplication later on for sake of simplicity. First, let's get it first running. So I'll jump back to the incremental generator. In the incremental generator, let's make this virtual. We override the initialize. Okay, we need to, of course, derive this one. C# incremental generator to C# generator benchmark. Okay, it must be, but I don't want to make it. Let's make it public. Later on, perhaps change it back to internal, and actually I want to make it internal, but let's do an visible to. I think I have the properties here already. I'll copy these over to the generator project and use internals visible to. Should be visible to incremental generator benchmark. Update the constructor name. Okay, so the generator, yes. This needs to be, let's make this generic T generator, where T generator is at least the I source generator, that's the earlier version. No, this is incorrect. This is incorrect. We need a need to create the generators. Okay, how do we do this? So we need here method create generator. This needs to be abstract. And this creates a, actually let's create these. Let's do these one. Let's say create generators so that we have this I source generator collection, because that's the basically the contract for the driver. Internal abstract create generators. No, let's create one. And call it, in the constructor, we shouldn't call abstract methods or virtual methods in constructors. Then I guess we need to move it to the initialization phase. I quite did not think this through entirely. Hope this works out. Okay, so we do create a generator and we add this generator to this collection. Okay, but we shouldn't do this in the... Is it actually compiling? Do not call overridable methods in constructors. Yeah, we do have a diagnostic for that. So let's call this in the initialization phase. Now this is nullable actually, yeah. Do we then still need it here? Actually, we can... Yeah, we do need them down there. Oops, still have some missing usings. Okay, so the options, let's... For simplicity, I will copy this. I will deal with the code duplication later on. Go to the incremental benchmark and paste it here, including the generator driver. And can we use covariance here? Not really. Let's have an overload with the C# incremental generator benchmark initialization context, which holds these. And okay, so with the generators, we should make these internal. And we will set them, okay, the driver and D also need to be internal. And create compilation. Needs to be internal. Let's make it protected. Oh, it only must be seen within the and the okay. Make all the fields internal. Inconsistent accessibility is less accessible. Okay, so this must be public. But I'll make the constructor protected internal. So that I kind of want to prevent for now that a user is deriving from that. And I'd like to start strict initially and later on, if a project wants to derive that, then we can always make rules less strict later on without breaking anything. But making them stricter afterwards would be a breaking change. Now we have to create a generator, and in our case, basically just now says return new T incremental generator. But we need to say as source generator here. Okay, and in the source generator version of things, we do the same. We derive here as well. We also need the project reference to C# generator benchmarking. And in here we just say new T source generator, which should fulfill that contract. Does it not? Oh, I need to make internals visible too for these as well. So for both incremental, but also source generator, yes. Okay. Yes, great. And let's see, where do we still have compiler errors? Okay, this is an extension method that I couldn't move, so I will copy it and remove the duplication later on. So we have here collections. This is a extension method which basically creates a nullable element, both both reference types and value types. And if it is not null, then yield returns it. So it's actually some of a singleton collection. But if it is null, then it's empty as well. Okay, where else? So we don't have the driver. Yes, in the C# generator benchmark, the initialize is, let's get rid of that. No, let's actually move that now to both. So let's jump to the derivatives, and here we have one. And with the incremental generator benchmark initialization context, which includes the driver options. And the other one, we just pasted in here. We do not include the driver options here. I will remove the duplication later. This is just void. Okay. Some more usings to add. And we have no driver options, because that's the version 3.8. Oh no, there are driver options. This looks weird. Why is there driver options? I thought they aren't in 3.8. Not sure. All right, are you missing a reference? No, I'm not. Okay. Let's do a .NET build on the project. We just do the themes to show me some wrong errors. .NET build. There must be some errors still, okay. So we have a problem with C# benchmarking tests. C# benchmarking tests. C#. Did I change? What did I change here? Ah, yes, I changed it to C0. Okay. And I believe I have... why is this an issue? This one doesn't define any project where we could have a downgrade. Not sure where the downgrade is coming from. Let's have a look at the other errors. It's also a basic reference. Okay. Analysis C# benchmarking tests. Well, we do refer to. This doesn't include any package. Oh, do I have? Perhaps I have a basic. Why are they included? I'll add a comment here to fix this later. Should be 3.0.0. Change it to what it was before. Yes, now we have some lies. Okay, does not contain a definition. Oh no, now we actually do have this error. Yes. Let's see if something else other than using the binder is inaccessible due to its protection level. That's here, okay. Are we? This seems to have been made public in a later version of Roslyn. In 3.8, it doesn't seem to be public. But if we set this to, let's say, 4.0.1, it is. No, it's still. How did this work before? Not sure. Oh no, it's referring to a different. That's the wrong binder. We don't want to refer to the binder from code analysis, but from system. I think that is in using a system.reflection. Yes, this resolves this issue. Okay. And some more. Okay, I guess it come now in the fix compiler error land. Now we have a lot of. Okay. Yes. So why does this not work? Because okay. Because in the we now need for this one benchmark here we still need the property, so we can do. Int t incremental generator, and let's assign this here. Can I do this in one? Can I say like return generator equals 2? No. So because it's different type, yes. So here's our incremental generator, and then we have it like this. This is internal nullable private set. Because we do have a test which requires that. Why is this an issue? This shouldn't be. So now we're back at our source generator test. Now we can use our new type and use our new types here as well. Include all the usings that we're missing. I think we are almost there, other than actually implementing the source generator, but the benchmarking should be quite complete. Let's find out. Some protection levels, but I guess if I click these through, they will disappear. Let's ask the CLI. No. Oh, okay, okay. I have, of course, I need to move the tests as well. For a starter, I will do internals visible to, and we'll move the tests to the base class later on as well. Move tests to C# to new C# generator tests project. All right, okay. So let's have a look at our new, let's run all the tests. Now we should have moved all the shareable logic between the incremental generator and the source generator to a base generator type. And we see the incremental tests still passing, but the new source generator tests are failing because we haven't implemented the actual source generator. So we see unexpected number of syntax trees, nothing happened. So basically not a move is to, for the tests, we have a C# for the previous tests, we have a test C# incremental generator, which defines a diagnostic, does all of this, and then for each and every available feature, we print something to text, and then so that we can then assert it. I will start with the first. So we have like a couple of minutes left to have it to complete the 2-hour sessions. I'll go as far as I can next minutes and do the rest then. Perhaps, I guess we continue then next time. But just let's fix one thing. Well, we can't really fix the test, but let's get a different error. So currently the unexpected number of syntax trees. So let's create the source code actually. What we did previously, we had a syntax provider on class declarations. In order to source generatorify that, our test C#, our non-incremental generator, needs to use doesn't need to use, but can use a syntax receiver. So we say register for syntax notifications. And this creates basically, receives a factory method for syntax receiver. We could also have a syntax receiver which has a context, and this context now has the semantic model, I think. I can't go to this type, but this should have the semantic model. But if we use the syntax receiver without this, so this one includes the semantic model, this one excludes the semantic model, where this has been added in 3.8, and the one with the semantic model is added in 3.9. But we don't need a semantic model, so let's use this syntax receiver. And the syntax receiver creator is a delegate, which returns an I syntax receiver. and the other delegate is a iSyntax context receiver. So we need a syntax receiver. Should we make a nested class? So I just add it to this file. Internal sealed class. I call it test syntax receiver. And the syntax receiver has the onVisit node, which basically I'll put them not side by side, but horizontal side by side. We see that for the down here we have the incremental generator. We have here this callback where we go for class declarations. So we basically do the same here. We say if the syntax node, for the syntax receiver receives each and every syntax node in the compilation and the input compilation. So we have the syntax node and we say if this is a class declaration, class declaration, we need a using, I suppose, yes. Then we add it to a list. Let's make a list of candidates. So we have a property, let's make a list of class declarations in our case. And well, actually, we just have syntax nodes down there. Don't cast them. How do we do it in this generator? We just get the length of nodes. Okay, so we have a list of syntax nodes. We call these candidates. And if it is a class declaration, then we add it to our candidates. Okay, so this is the syntax receiver part. I'll close that down there. Where we can now, well, we could also have our delegate, so we can say internal static iSyntax receiver returning create method, which news our syntax receiver. So we can say test syntax receiver.create. And another thing we could do in the initialization phase is register for post initialization, but we don't need that here. We can now go to the execution phase where we now get the syntax receiver. So we can say we need our syntax receiver. Receiver is context dot. We have both properties. We have the syntax context receiver and the syntax receiver. But since we registered the syntax receiver, we need to use the syntax receiver here. If we use the other one, if we use the other delegate, the create context receiver, then we have the other property. We actually can have a look at this in the F1 help where we see that this has been added in 3.8, but the syntax context receiver has been added in 3.9. And we know the type. We can cast this as, actually let's, I learned recently the unsafe as cast, so I want to use that. Unsafe dot as test syntax receiver, because we know this is, although it's unsafe, we know this is a test syntax receiver because we define it up here. And can then ask the receiver to, let's fix the test. Let's say I want to context dot add source. I think let's call it, let's do a const here, private const string hint name is name of this class.g.cs, and we add the hint name and we just add an empty source. Let's run the test, and I guess the error should now go away that we now have one syntax node. But the hint name is different, yeah. Oh, I actually used the type name. Sharp source generator. Okay, so let's do a type of here. I can't use type of in const, yeah. Okay, and now we get, now it says, now our test says, okay, it's all minus because we haven't produced anything. I will grab that. Let's do a string code. Let's make an interpolated verbatim string. Okay, we do need the auto-generated. On top, we enable nullable. Then we have a space, then we open a comment, and then we print the number of nodes. And the number of nodes is not 0, but it is from our receiver. Receiver has the candidates and the length of this one. Count. It's a collection. Okay. And let's put the code into the output. Dereference of possible null reference exception. Yeah, let's force this to be not null. We know it's not null. Manuel is writing, I would personally debug assert the unsafe cast. That sounds absolutely reasonable. That's a great idea. Just to be sure. So, okay, if I would have an error, then a test would fail saying, okay, there is something wrong. Yeah, that's a great idea. I love it. Debug.assert. We assert that the syntax receiver is of type test syntax receiver. And yeah, Manuel says hi. Hello, thanks for joining. That's a great idea, I love it. So if I would do an error, and I don't know, let's say I forgot to register this. And if I run the test, it should give me a nice message that this expectation has failed. It does not. So because we are within a generator, it just says the generator. There it is. Okay. It says, let me put this into a text. So it says that this generator failed to generate sources. It will not contribute to the output of the compilation. The exception was of type debug assert exception with the message debug failed with something. So perhaps we should also add a message. Unexpected syntax receiver. And if we run the test again, this is what I said in the beginning. When a test fails, it should give an indicator of where it fails. So it says exception was of type debug with message unexpected syntax receiver. So I could then copy this, search in my solution, and interesting, the file all search doesn't find it. Not sure, but yeah, there it is. Okay, and now when we add it again, this should be fine. I guess then we can also get rid of the, if the compiler knows that this is, I guess can we get rid of this exclamation point? Yes, we can. We don't get the warning down here because with the debug assert, the compiler understands because debug assert is annotated with does not return if this condition is not met. And in this condition, we say that the syntax receiver is of type test syntax receiver. So the compiler knows it is that type, and then this is not null anymore. So here we don't have the nullable warning. That's cool. So the debug assert serves two advantages here actually. And in release mode, it's not there, so it gets compiled out, so there is no performance hit. Well, performance hit, it's an fcheck. Okay, so why is the test failing? Yeah, so we see everything is great, but from down there, here we still have the minuses, so we got everything so far. Now it's the rest which doesn't work. Let's have a look at the other test as well. The other test actually has nodes. This one does not create anything. Okay. It should. Let's jump to the test. We invoke, we inspect. It should have two nodes, but it doesn't generate any output. Ah, yes, because we don't take care of the additional texts yet. Because what we have in the other generator, in the test incremental generator, we actually use the additional texts and create files from that. So let's actually, I will steal that. I should move this also in some base class to avoid the duplication. I will take care of this later. But how do we get the additional texts? This is all in the context. So this is unlike a incremental generator where we define the pipeline and what we actually observe. In the iSource generator, we have everything all the time. So we have here our additional files. Okay, I'm actually having a string builder here. Let's create it here. The hint name, this can be local. And we have a default file name extension. There it is. All right. Now this should. So I don't have the. I don't have the additional files, do I? No. Yes, I do. Yes, I do. So no, I don't. Do I not? If we jump to the test, we do define additional texts here. This should be added. But it still says unexpected number of, unexpected number of diagnostics. Haha, my bad. Diagnostics. We also need to produce diagnostics, so I'm gonna steal that as well. So we have the nodes. Those nodes are, in our case, syntax receiver. Receiver candidates. We also need the rule. Yeah, I will get rid of the code duplication later on. Let's get it green first, then we do the refactoring. Feature nullable reference types is not available in C# 7.3. that's correct. I need to set the language version. Oh, yes, because this is conditional. Actually, I'll go ahead and copy all of it. And then get it. Let's copy all of it. And let's get it. So we don't have the executions because it's a incremental generator. It's a non-incremental generator. So let's get rid of these. Let's the language version. Yes, language version is a missing using, and the parse options, we get everything from the context. So we have context dot parse options. But these parse options are actually, okay, let's do have a local variable parse options, because these parse options are general parse options, but since we know we are in C#, we can say, we can cast them to C# parse options. Here we have the nodes, which are the receiver, I removed the receiver code. Sorry for that. Which is receiver.candidates. Receiver.candidates. Okay. The compilation is in context.compilation, but again, this is only the base compilation, it's not a C# compilation. This is why we allow unsafe. Is this in the base? Or is this in the C# compilation? Let's find out. Yeah, so again, we need to cast it. So I'll have a compilation local for the C# compilation, and cast these as well. All right. So this is context metadata. Context does not have metadata references. Okay. It doesn't. Has this been added in a later version, perhaps? Metadata references. No, it doesn't. Okay. C# source generator, the 3.9, doesn't have the metadata references. Okay, so that's actually a feature that we don't have. So let's get rid of these. And what's with the analyzer config options? Okay. Candidates.count, not length. And here we have additional texts. So that's context.additional texts. And here we have nodes, which is context. No, that's the receiver. Candidates. And this is not called additional text, but additional files. Okay, so they renamed that as well between source generator and incremental generators. I now get more of a feeling of what is different between the two, so I need to update my talk on source generators, that we don't have metadata references here. That means from the test, I should actually remove that line. So we don't have the metadata references. So let's get rid of these, both of them, and let's run the tests. Could be passing. They're not. Let's see the difference. The difference is that it's called nodes and candidates here. Okay. So I called them candidates. Okay. Run them again. Now I actually kind of still finish it. A bit over time, but I want to get them green now. And they are green. So let's run all the tests. And actually now we now support source generators as well. So we have one package for incremental generators that we finished previously. Now an additional package for source generators. And the thing is that the incremental generator package, no, not to the test, let's go to the production project. The incremental generator project is actually requiring 4.0.1. This is where incremental generators have been added, Roslyn 4. And the source generator package for, okay, this is wrong, this should be 3.8.0 because this is where incremental generators, no, sorry, source generators have been added, which was the .NET 5 SDK, Roslyn 3.8. And this compiles as well. Let's run the tests again. No, it does not. Version conflict. Now I have the version conflict again. Okay. I'll have a look at it in the CLI. C# source generator benchmarking tests. How? They are, I don't understand. So here we are in a test project and they don't really include any additional project, but refer to the source generator benchmarking project, which is this one. And this one has C# 3.8, but also depends on this benchmarking on the general benchmarking project. This one is also 3.8, so I guess we actually could get rid of this package reference, but this shouldn't be the issue. Where's the 3.9 coming from? Oh, that's in tests because of the basic reference assemblies. Okay. So I'm including them everywhere. I think I understand the problem now. Because I do have in the tests a directory build.props where I include this package that I showed earlier, the basic reference assemblies. And I believe this one targets, let's see the dependencies on this one. .9. Okay, so all the test projects should at least be 3.9, which means that the source generator package here must be 3.9. So let's manage. Do I have it? Yes, C#. I could have a higher version, but let's go the minimum required 3.9. Which should resolve this issue. And it seems to. Let's test. Green, green, red. So we have language version C# 9, but okay, I think because we use the default language version, and since we now use a higher package version, the default here is no longer 10, but a lower one, actually 9. The default. Because, okay, I copied this over from this generator project, from the incremental generator project, and there we have Roslyn 4.0, which is default C# 10. Yeah, but this is not available in 3.8 yet. There we have 9. So that makes sense. And this should make it green, and now all the tests are green again. Perfect. Okay, and basically now we support source generators as well. But first, and this will be then the next package version, pre-release 2. First, I'll improve the error message on wrong locations. Then I add some documentation. Then I release the incremental generator package. After that, I'll do the cleanup, remove the code duplication that we introduced, and will then also publish this source generator package. And I guess then in the next session, oh, Stuart is joining. Hello, thanks for joining. I'm afraid I'm quite closing up already, and we'll continue in a week, minus 2 hours. So we almost finished incremental generators. Documentation and a better error message is of need, and then I will publish this soon, definitely within the next week, before the next session in a week. I will then have the pre-release published at NuGet.org, so you could try those out as well if you wish. But we did start to implement iSource generator. Actually, we almost finished it. It was because they do share a lot of logic. The only difference is that iSource generators do not support metadata references. And the other difference is that, actually I should clean this up, shouldn't I? Since they don't support it, I should remove from the shared context project. Oh, that's a lot of files. From the shared initialization context project, I should get rid of these metadata references and move them to the derived incremental generator because they support it. Then I believe there is one build error because it's not in the base. How do we solve that? We could do it like oh no, never mind. That still makes sense. That still makes sense from the compilation point of view. But we can't, for the compilation it still makes sense if we want to use a different assembly version, different references basically. But we can't access these in the source generator directly. But that's all right. Okay, so that's actually good. I revert that. That's good to have like it is. I students writing, try to catch the next one. I would love it. I usually start at 7 UTC. I think this is currently 8 o'clock London time or UK time. Every Sunday. Okay, that's still green. So the meta difference are all right, but we can't in a source generator, in this Roslyn 3.8 source generator, we can't access the metadata references directly. However, they are still part of the semantic model. So if the metadata references include a certain type, such as what we saw earlier, the is external init type that you need in order to enable the init only keyword on on C# 10 targets which target a lower framework than .NET 5, where this type isn't available. So this type needs to be there. We can still ask if this type is available in the semantic model, but we can't access the metadata references directly in source generators. But in incremental generators, we can. Since Roslyn 4.2, because there was a bug in 4.0. Oh, that's a lot of information. I should list this all in a bit of a bit of a more written summary. And yeah, that is it for today. As always, all the interesting links that we explored during the session, I will add here to have a comprehensive dictionary library. And before the next session launches, I will have at least this package published, and I'll get rid of the code duplication that we introduced today to prepare launching that one as well. And then I guess this is already a lie. So we will do some cleanup for the iSource generator, but we will definitely finish source generators next time, and then start implementing one of the other components benchmarking. We then have 4 left, so incremental generators are almost done. We will finish these next time, and then I'm not sure. I guess diagnostic analyzers, either diagnostic analyzers or code refactoring providers. I guess I go with analyzers because they're more prominent. So we will start implementing benchmarking types for diagnostic analyzers. Manuel writes, great session. Actually got something done. Woohoo! Thank you very much for joining in live. I really appreciate it. And thank you for the tip, for the feedback about the debugger cert. That's really great. So that's my learning from today. If you use, where do we have that? I think we have it in our test source generator. If you use an unsafe ascast, then always have a debugger cert here as well with an explicit assertion message, so that a test, if there is an error, a test immediately indicates what the issue is. And with that, I thank you very much for staying a while and listening. May Roslyn be with you, and perhaps I get to see you or write with you in a week, minus 2.5 hours. Goodbye.